command the particular cell. For example, this is a cell, right? I'm using control enter to execute that. To come to the to open a new uh, here, I'm using alt enter. Okay. So with the shortcuts we can able to make it this easily. So now I'm go to the third library, which is Matplotlib. I will explain like what Matplotlib is here. It's not something one different thing. It's more like so we'll be having Tableau and all these things, right? Tableau, Power BI. So those are some visualization tools. So in Python also we are having a similar library which actually gives pretty much the same kind of graphs or bar graphs, some pie plots, all these graphs. We can able to handle this with using this particular library called as Matplotlib. So Matplotlib, and there's other library called as Seaborn. So there's a spring Seaborn. So with these two libraries, Matplotlib and Seaborn, we can able to draw some graphs. We can able to find out like what how a particular feature or what how a particular uh, I mean, particular column is related to other column. So let's say there are two columns called as A and B, and uh, in that, I mean, let's say there are two columns called as uh, basing on the weight, basing on the age, we are having height of 10 different students. Age is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the height is also like 2 foot, 2.5, 3, 4, 5, 6. I mean, it's increasing in a directly, it's directly proportional age and height. Okay, so in that case, if this two feature with these two features, one feature is directly related to other thing, which is like one feature is directly proportional to other feature. If the age is increasing, height is increasing till certain extent. Okay, so uh, what I'm trying to say is these two things are directly proportional, right? But we can't able to see that, we can't able to calculate that manually, right? It's a clumsy process and it's gonna take a while. So with the graph, when you want to see some in terms of visualization, the graph can be easy. For example, let me open that. Okay, so let's say this is age and this is height, and with the age increases, height is increasing. Now you can able to really say like, okay, with age is increasing, height is increasing. But if I give a data set like around 1 million records, it's going to be a very difficult process. We can't always look into the data. Okay, this is directly proportional, this is directly proportional. It's like a clumsy process. So rather than that, we always, it's better to rely on some certain graphs. So to do that on graphs, we are actually importing this matplotlib. Okay. I'm importing this now. I'm not using Seaborn. Seaborn is more like a advanced level of Matplotlib. You can say that, but Matplotlib gives a general context and the basic. We can cover all the basic this graphs in Matplotlib. Matplotlib is actually pretty much enough. Seaborn is used for some pretty much complex algorithms. Now, after this, we can have. I'll be writing some other line here. Okay. So what this line means, what I'm doing here is here this matplotlib, I want to keep it inline, which means if I'm just giving a certain command while using matplotlib, I want the final diagram to be printed then there only. You'll be knowing when I'm doing that. But here inline means I want this diagram or figure to be on the same this thing. I don't want to open a new window diagram or some bar graph. I just want to open this here, then and there only. Okay, that's the reason I'm using inline. But I'll be mentioning that when I'm using this particular matplotlib so that you'll know this. So now, once we imported all the main three libraries, which we're going to use this to run this linear regression model. Let me write this as well. Refreshing. Okay. Now, after importing all these three libraries, now let's focus on the data set. So, there are some certain data sets in the sklearn as well. So we're gonna use the same data sets. So one thing we can use a CSV data set, we can use an Excel data set, we can use any kind of data set. But not, right now I'm using data set from a certain library. That's it. So that's the reason I'm just using a library name here from sklearn, which is scikit-learn dot datasets. I'm importing a data set called as load Boston. Okay, so remember guys, it's very important. So you're not I'm not using any data set from my particular desktop or any from any other Google location. I'm just using it from a library. So this is the dataset name. Load wash is a dataset name, and this is the library name from sklearn dot datasets. I'm importing this one. That's it. Okay. After this, now load Boston is something pretty much complex name. So I want to give I want to initialize a variable called as load Boston. So Boston is nothing but load Boston. I want to, whenever I'm calling my data set, I want that to be a pretty simple. So that's the reason I want to use Boston, not load Boston. Now let's see what is there in the Boston. Okay, let's see what is there. Uh, so this is a Boston data set. Hmm. Oh, sorry. So function. Okay, so this is a data set using. So this is how the data looks like. The data is a bit clumsy, but later you'll get know that like the data is in the array format. Like you're having all these values, and the target is this one. These are the feature names: Crim, Xen, Indus, Cas, Nox, RM, Age, Test, Rad. We'll do later we'll be converting this data into a particular data frame, then it will be just like an Excel format. Right now the data is clumsy, but we're gonna transform this. Boston.tsc. Sorry, it's a function. Okay, so this is a Boston data set. So Boston house pricing data set. So here what I'm trying to say is, what I'm trying to find out is, there are some certain houses in Boston. So, so I want to predict what would be the housing prices if I was given a new houses. Okay, let's say there are 100 houses in Boston. So I know the houses, right? Prices all the houses. Okay, so there are some, let's say there are some 10 new houses coming in Boston. I don't know what is the houses, but I know some information about the houses. For example, what is the information I know? So these are the particular columns I'm having in this data set. Crim. So crim is nothing but this is a description for this particular because we don't know what the crim is, right? We don't know what is Zedden means, what is Indus means. So I'm just giving so these crim is a per capita crime rate by town. ZN is proportion of residential land zone for lots of over 25,000 square feet. So this particular columns, it's giving me like what is what. So that basing on this, I'll be trying to find out what could be the housing price of those newly 10 added uh, houses. Okay, you got the point, right? This data is taken from. So this is more like how this data set came into the picture and all these things because we are using this particular data set from a certain library, right? So that's the reason. So now I gave what the Boston data is. I told you what is targeting that data set. Now, now let me try to find out what are the features in the. I mean, which are column features are nothing but this thing, crim and all these things. Okay, feature. So these are feature names, crim, Z, and Indus. So this is what I'm talking about. So these are the features involved in this particular data set. Now let me give other. Sorry. Okay. Now what I'm doing, we already talked about pandas. What we are doing in pandas. Now we're gonna do the same thing. So we're gonna transfer because the data set is clumsy, right? So I want to convert the data frame. So for that, I'm using pandas, PD data frame. Remember, Python is we need to use caps. It's case sensitive language, so always we need to make sure like whenever we're using this particular function names or whatever it is, it should be used as it is. So D should be capital and F should be capital, and only it will work, otherwise you're going to throw an error. And PD should be small because we are declaring here as a small PD. It's not a capital PD. Okay, so that's the reason I'm using a certain naming convention whenever I'm trying to find out and trying to give the function or whenever I want to use this function. So I'm declaring this pd.data frame. What is the data? Boston.data. This is the data I would like to give. What are the columns? Columns is equal to Boston dot feature names. So what I'm doing here, I'm declaring a PD. I want to convert this particular Boston.data. Already showed you what is Boston.data. That's the complete data we are having. This is, yeah, this is a Boston data. So I want to convert this complete Boston data into a data frame. I do have data right now, but I don't have columns, right? So what are the columns I'm using? So these are the feature names, right? I told you, right? Crim, Z, and all these things. So for I'm assigning this particular column names to the data. So that is what I'm giving it here. So after I run this, I want to see how the data set looks like. Now you're gonna see. Now you're gonna have a good data, good understanding of what this data is. Okay. So see, now it looks good. We are having 505 rows and around 13 columns. So Crimson and Indus are my column names. So now we have good understanding of what is data set is. So basing on all these things, I need to find out what is the price of the, what could be the price of my data set. Now, what I'm, let me pull out some more information from the data set. Okay, since I do have data set now, I want to explain you some good functionalities, what we can do here. For example, dataset.head means head function is used to give us the top 5 columns from the dataset. So it just gave me 5 columns, 1, 2, 3, 4, 5. Okay. So it gives me only the top five, because head means the header portion, right? So I can also mention like I don't want five columns, I want 10 columns. So it gives me like 10 columns. Okay. At the same time, I do have other thing called as tail. Data set dot tail gives me last five columns, 501 to 505. It gives me last five columns. Sorry, five rows. At the same time, I also can also say like I want 10 last 10 values. So it gives me a tail dot tail. If I give you 10, passes 10 into this particular function called as tail, it gives me the last 10 values. Okay. Now I want to find out the information. There is other function called as info. With the info, uh, it gives me like some details about my all the rows, all the columns. For crim, it is saying their total number of values are 506. It is a non-null value, and the data type is float. So all my columns are a float data type. It gives me float value, the what is the memory size of this data set. It gives all these kind of values. Okay. You just want to find out like what is the size of the data set, all. I want to find out. I want to see that like because I want to make sure like how many columns are there, how many what's the data types of all these things. To find out, I'm just giving this dot info. Okay. After that, data set dot describe. So so what is it is trying to find out give me all the statistical information for this particular data set. So with dot describe, it gives me like for crim what is a count, how many counts are there, 506. I told you, right? There are 506 records. And what is a mean value, what is the mean value of this particular crim. I mean, it gives me like uh, the first one for crim, we are having like 505, right? I'm trying to find out the mean value of this records, this particular column. So it gives me all this information. What's the mean? What's the standard deviation? What is a minimum value? What is at 25% percentile? What is the value? At 50% percentile, what is the value? At 75, what is the value? What is the max value? It's giving me this particular statistical things for all my columns. So that is what a dot describe does. Now, uh, now, still I'm gonna check some more values because it's null. So for all my 505 records, it is saying whether there is any null values or not. Because I told you, right? If there are null values, then it doesn't give me a good. It doesn't serve me good purpose. This particular data set. Why? Because uh, let's say for crim, all the values are null values. Then it's no point for me to use this particular value, right? So it's not helping me to predict certain data, certain value of the house, price of a house or anything like that. So that's make sure like how many null values are there. So is null. I want to find out how many counts are there which are having values. Oh, sorry. Okay, so there are zero values which are having null values for crim, zero for zn, z for zns, which means my data set it's perfect. It doesn't have null values, so I don't want to deal with the null values. For example, if I'm having a lot of null values, I told you, right? Sometimes if, there are like 100 values, and in that 100 values, two values are missing. So what I'll be doing for the two values, I'll be imputing that with the mean value. Let's say. mm, So this is my mean value. 10.5 is my average. Okay, here. So let's say there are other two values. Uh, for me, let's say this is my age. This is my this is my age of my different students. Students called as A, B, C, like that. Let's say we are having different table names of a person. I'm just giving for that, and there are two persons as uh, okay. I don't know the names of I don't know the ages of that particular persons. I'm old, but I know mean of this value is 10.5. So what I'll be doing here, I'll give a mean value here. I'll impute this. This is called as imputation. Whenever I don't know the values of certain records, like let's say there are very few records, I'll be imputing it to the mean or median or more, basing on the problem data set or data set. So I'll be doing the same thing here. If I do have some certain null value, but I don't have null values. So what I'm saying is I don't want to take care of all these things. I don't want to take care of what imputing I'll be doing or anything like that. So I'm good, right? After this, let's talk let's see what are the other functions we can use for this particular thing. Correlation. Okay, so this is a very interesting one. So these are the records I'm having. These are the value. These are the columns I'm having. Crim, Z, and Indus. Just pay attention here. For example, for Crim is directly proportional to Crim. For example, this particular record 0.28960 and 0.28960 both are directly proportional, which means correlation is how much a particular value is proportional to other one. If it is 1, the value should be equal. If it is like if it's like 0.4, for 10 value in index, the crim value is like 0.60, 0.40. For 10, the value is 4 there because it's only correlated by only 0.40. You getting it right? So here, if I'm saying like I'm trying to find out the relation between Indus and Crim, Cas, this is like Cas and Crim. This is like Knox and Crim. So with this, I'll be knowing like, okay, how the particular columns are there, how it is related to other columns. So with this only, I'll be knowing the relationship between the two columns. I told you in the before instance, like there are two columns, A and B. A is nothing but the ages of the person, and B is nothing but in column B we're having heights. So so A is proportional to B. I want to find out how much the proportionality is there. Like I want to find out in numbers. So this is the correlation thing. We're gonna see like how a particular number is related to a particular column is related to other columns. So crim is nice. If you see here, with this is Zn, right? Okay, so this is crim, for example. Crim is not directly proportional with Cn. It is not directly proportional to 0.40. It is far better. 0.40 is fine at least. Minus 0.5, not at all good. 0.40, not at all. It's okay. Minus 0.21, it's okay. 0.62, it's good actually. Cream and red is actually fitting together. For every, let's say if the crim value is 10, the rad value is 6, and it's proportional. So that's what I'm trying to find out here. I want to find out the correlation here. After I found out the correlation, I'm sorry, actually, I want to use pair plot here. So that's the reason I'm uh, importing Seaborn also here. Seaborn as SNS. I told you right. There are other library as well in terms of Matplotlib. Seaborn is on the advanced thing. So I want to use this here because I want to show you like what the correlation is doing. Correlation is pretty a bit clumsy here. The reason is it's having all the numbers like a 0 to like minus 1 to +1. So all these things, right? So I want to see this in terms of in a diagram way. With the diagram way, we can able to clearly understand whether it's directly proportional or not directly proportional. So that's the reason I'm using CNS, SNS, Seaborn, because only Seaborn has got a particular library, particular function called as or particular plot called as pair plot. So pair plot is the one which we gonna use to find out a particular column is correlated to other column or not. Okay, now we ran this, but also now send this. What I'm doing here is for my particular data set, just I'm asking me to give a particular pair plot for all my data set. Okay, so that's what I'm giving. So it's going to take away why, because it is trying to compute all the uh, here. So it gives me the similar records here. What happened? Okay, okay, I got it. I got it. So this particular record, how many diagrams are there? You know what? We are having same number of diagrams, whatever we are having here. So it is doing the same thing. What is doing here? But so how CRIM is related? How ZN is related? It is giving me information of all the graphs, how a particular one is related to others. So it is like it's okay. It is directly proportional. Nothing is directly proportional here. You see, most of the graphs here are scatterly plotted. For example, this thing. But we previously discussed about this outlier thing. So this is how our outlier looks like. Let's say for this particular one, this is the outlier, and these are the outliers. So you know what? For a particular column called as RAD and LSTAT, this is how, or let's say for age and LSTAT, this is what the graph looks like. So this is age and this LSTAT. So I plot the values here. This is how the values looks like. So what I'm trying to say is, for every column, we are actually having pair plots here, if you can see that. But it just takes time to analyze, to look for each and every graph. For example, this is one graph. Like this, we are having a lot of graphs here. So we are having age and uh, RM and now we are seeing like, okay, it is proportional actually. This RM and that the LSAT one. It is a bit proportional, but it is indirectly proportional. If it is directly proportional, it would be like this. But since it is indirectly proportional, we're calling it like this. Okay. So a clear picture like what is what the pair plot is doing now. And people gonna ask us like, okay, when we are given a particular data set, we're gonna say like, we're gonna do the exploit data analysis. I told you exploit data, EDA, right? Exploited data analysis. So this is what EDA means. So in EDA, we are doing like what is the correlation here, and we are trying to give a pair plot out of it. So to do this, this is nothing but an exploit data analysis. In exploit data analysis, we are like trying to exploit some details. Like I don't know the story of the data. I just want to know how